Hi everybody. Today we're gonna do our last day of notes. Trying to think, is there anything else? No. It's our last day of video notes for this unit. There we go. That's the rest of the sentence. So yeah, it's 3 pages. It's not super long stuff. I will say this stuff has there's a couple of formulas that you will need to memorize because they are not on your formula sheet. Okay? Now, I have a couple tricks to help you remember them. So that'll help you out a little bit. Okay? So today we're doing percent of change and simple interest. So again, we're doing percents that you guys love, and let's go ahead and get started. So, percent of change is the percentage of a total that an amount has changed by. So when we say we're going to go up in price, we don't just double it or triple it. We can go up like part of it. So we can get a certain percentage and increase it by that much. Very similar to markups, okay? That's a percentage of change. Percent of increase would just be meaning that it's actually increasing the amount, or a percent of decrease would be lowering the amount, decreasing it. Okay? Now, if I'm going too fast, don't forget to pause the video. So the formula for it is the new amount minus the old amount, the original amount, all over the original amount, and then multiply it by 100 to get the actual percentage. So when we do new minus original over the original, it gives us a decimal. We're then going to convert that decimal to a percentage just by multiplying by 100. And an easy way to remember what gets subtracted and divided and everything is that if you do n minus o over o, it spells out no. So just think, when you hear percent of change, think no. You don't want to do it, but you have to. And you're gonna hear me say no every time we do percent of change now. So hopefully that'll help you remember the formula. All right, so these next parts, I could not for the life of me remember what these blanks were supposed to be. And when I went through the notes and I tried to do everything else, it didn't click with me, so it's not important. The stuff that I crossed out in the red scribble, you can just cross out. Not as you don't have to be. It doesn't have to be red, but you can just go ahead and cross that out. The first bullet point, though, we can. The percent of change tells the percent of an amount has increased or decreased in relation to the original amount. It's basically a very wordy way of saying the definition I just did. So let's go ahead and do the example because I feel like you guys learn more from the examples than the words anyway. Okay, so we have to find the percent of change from 54 inches to 63 inches. Well, we're going from 54 inches. Okay, so that's our old amount. To 63 inches, that would be our new amount. I have a blue line, there we go. And because we're going from 54 to 63, that means we're increasing it. So this is actually going to be a percent what is it called? Why can I not remember these words? Percent of increase. Okay? An increased percent. So we're going to go ahead and set it up. So the way we get the percentage by doing the new 63 minus the old 54 all over the original, which is 54, and we multiply it by 100. So the very first thing we're going to do, we're following GEMDAS for this, order of operations. So we are going to do this subtraction first because this is actually a group. When it's a fraction bar, we can't use the fraction bar yet, which is division, until we have a single number up here. So we're going to get a single number first. So the very first step we're going to do is subtract. Okay, so 63 minus 54. I'm just going to rewrite the whole thing. We're still going to have the 54 on the bottom, but 63 minus 54 is 9. Okay, now the next step for GEMDAS is to do this division. 9 divided by 54, we can do that. I think it comes out to be a repeating decimal, so we're going to round it off. So it ends up coming out to be 1.67. I just rounded it off with a 7. And then we can go ahead and multiply. Multiply. I'm going to move this over here. Alright, so we multiply together. We get 16.7% increase. Okay, so that's all we're doing for this. So the next one is your try on your own. Very, very similar to the one we just did. So go ahead and try that on your own. You can either pause the video now, or you can come back to it later. Okay, We're going to go ahead on to example 2, which is more of a real world problem, okay? So in 1975, the price of gasoline was 0.57 cents a gallon. I don't know why I said 57 cents a gallon. In 2000, the average price per gallon was $1.47. I don't know why I can't read money today. Find the percentage change. Is it a percent of increase or decrease? Well, that we can answer pretty quickly because this was our old amount, 57 cents, because it was in 1975. Believe it or not, that was before I was even born. To 2000, which is a newer year, so $1.47 is the new amount. So from going from old to new, we actually increased the price of gas, so it's a percent increase. Okay, so now we just need to figure out the actual percentage, and we're good. So we set up our equation, and I'm going to do no again. So 1.47 is our new, minus our old, which is 57 cents. Okay, all of that over our old, which is 57 cents, and then we multiply it by 100. So again, first thing we're going to do is subtraction, because we need to get this to a single number. 1.47 minus 0.57, that actually comes out to be 90 cents, or 0.9, over the over the 57 cents. Now I can do my division, and I get, again, I rounded it off, so I get 1.58, and then I go ahead and multiply. So it was actually a 158% increase. Now, the reason it's so high is because 100% increase means you double it. Okay? If I was going to double the price of this, that would be $1.04, I think. $1.14. Yeah, $1.14. That's clearly still less than that. So I more than doubled it, which means I'm going over the 100%. Okay? So 158% is actually like a good answer. Like, it makes sense because I more than doubled it, so it's clearly going to be over 100%. Okay? So, you have a try on your own. Ooh, I gave you a little bit harder one. Just because it has bigger numbers in it. So you're going to go ahead and do this one. Same way I did mine. Okay? Let's try that one on your own. Now we're going to go ahead on to example 3, which is still a percent of change problem, but it's a little bit different because you read it, you have 150 songs on your iPod. I know, this is an iPod. Who has an iPod? So old. You delete 20% of the songs. How many songs are left on your iPod? Well, this is actually a percent of change because we're talking about a change in the amount. Okay? They gave us the actual percentage. Okay, so we decrease because we're deleting. So it's a percent of decrease. But they gave us the actual percentage, so we're not looking for that. We're looking for the new number of songs, right? So our unknown is how many songs they have left, the new number. All right? So we're going to use the same formula, but we're actually going to go ahead and put in the numbers we have and just use an X for the ones we don't. Okay? Now we have the 20%, but because it was a decrease, I'm actually going to write it in as -20 to show that it's a decrease. Okay? That's how I differentiate when I put it in a problem from an increase and a decrease. I just say this is going to be negative, meaning it's going down. Okay? So I was supposed to do no. I don't have my N for no, so I'm going to put in an X there. So X, which is my new, minus the 150 songs, the original songs I had on there, all over the 150, the original songs, times 100. So now, I'm not just doing order of operations here. I actually have to solve it. So I'm going to undo the order of operations to get it. So I use something in my class. It's called SADMEG. And next time we have SOAR, we're going to talk about SADMEG. It's the reverse of GEMDAS, and it allows you to go ahead and just work backwards. So here, to get x by itself, I can't add 150 to it yet because it's being divided by 150. And I can't just go ahead and undo this 150 because it's all being multiplied with 100. So the very first thing I need to do is divide. And I'm going to divide both sides by the 100 because I want to get that out of the way first. That's actually the farthest thing from x, so I can take care of it very easily. Divide everything by 100. I gotta move my little recording thing again. Divide everything by 100, so now this becomes negative 0.2. I still have the x minus 150. I still have the 150 on the bottom, but the 100 is gone. Okay? The next thing I would do to get x by itself is to get rid of this 150 on the bottom. Okay? Because I can't take away this yet because it's being divided by 150. So I want to go ahead and just get rid of this. To undo this divided by 150, I multiply both sides by it. So I'm going to multiply somewhere both sides by 150. These guys cancel out. Same thing happens on the other side because I got to keep it equal. So I can do this multiplication, and I get negative 30. The bottom, the denominator of 150 and what I'm multiplying by cancel each other out. Okay? So I'm left with negative 30 equals x minus 150. Now I can go ahead and add 150 to both sides to get x by itself. I get x equals 120 songs left. And then, that's my answer. And then I just realized, like, this problem, you're not going to see very often because it's not strictly a percentage change problem. Like, yes, you can do it with percentage change. That's not necessarily it isn't the only way to do it, and it's probably not even the only way, it's not even the way I would do it. I would just try to figure out what 20% of 150 is, and then subtract it from it. Okay? That's another way you could do it. So if you don't like this way, which, to be very honest, I'm not a big fan of, it's okay, because you can do the is of percentage thing that we did last time, and find it that way. Okay? So, this one you're going to go ahead and try on your own. I would like you to try one of them the way I showed you with the percentage change, and if you want to do the other one, figuring out like the is of, that's totally fine. Okay? So go ahead and try and figure this one out. We will talk about all these try on your own next time in class. Okay? Before you leave, don't leave yet because there's still more to this video. Okay? This is all percent of change. We're going to do one more topic. Okay? And it's simple interest. Percent of change and simple interest stuff, to be very honest, maybe shows up like twice on your SOL. Okay? So, but simple interest is actually simple. So the name is actually very accurate. So simple interest is money that you can earn on investments. Alright? So when we put money into a bank, we can actually earn money just by leaving it in a bank. A lot of times you'll hear percentages of banks and cars and stuff like that, and that's actually talking about interest. Okay? A principal is money invested or borrowed or lent out or so it's just the money, like the initial amount, how much you're starting, like what kind of money we're playing with here. Okay? Simple interest is also going to make a big deal in, we're going to come back to it with finance park stuff that we do. Okay? Here's where it comes into play with percentages, because the rate is the percentage of increase your money can increase by. Okay? So it tells you how much it's going to increase by, and it gives it to you as a percentage. However, in order to use it, we have to use it as a decimal. So whatever the percentage is, just divide it by 100, and that changes it to a decimal. Okay? And then time is the length of the investment, and we need that to be in years. Okay? The formula for it is the simple interest equals the principal, the P, times the rate, times the time. Okay? And a way to remember it is I pretty. Just I'm pretty. Okay? That's how you remember it. So, a couple of examples, and then you do one on your own. So, example 4, Chris deposited $2,000 in a savings account at the interest rate of 40 4% per year. How much simple interest will he earn in over 18 months? So let's go ahead and see what information. So the principal here is the $2,000 he's putting into a savings account. That's my P. The 4% is my rate, and I need it to be a decimal, so I go ahead and divide 4 by 100. I get 0.04. And the time is 18 months. 18 months is 1.5 years. Okay, so just divide it by 12 when you have it in months. So now I just go ahead and then I don't know what my interest is. That's what they're asking about. So let's go ahead and plug in the stuff that we know into this formula. So we don't know I, but we know P is 2000, R is 0.04, and time is 1.5. Now all I have to do is just go ahead and multiply it, and I'll get my simple interest. So $2,000 times 0.04 comes out to be 80. 80 times 1.5 is 120. And because we're talking about interest, and interest is money, it's $120 in interest. So just by leaving his money in the savings account and not touching it for a year and a half, he earned $120. I think that's a very, very easy way to earn money. So, all right, let's look at Sophia. She invested $1,500 at an annual rate of 5%. How long will it take Sophia until she earns $1,125 in interest? Okay, let's go through. So the principal amount was $1,500. The rate that she's earning is 5%. We divide it by 100, so 0.05. We don't know how long she's leaving in there, so we don't know the time. But we know what we want her interest to be, 1,125. So we plug in the stuff we know. 1,125 goes in for I, 1,500 goes in for P, 0.05 for R, and then we leave T as is. Okay, I'm going to go ahead and multiply this because I can. And when I get is 75. Now to get T by itself, I divide both sides by 75. So T comes out to be 15 years. So if she leaves her money alone for 15 years, she can earn $1,000 or 1,125. It's not the quickest way to earn money, but it is one of the easiest ways to earn money. Okay? So you guys are going to go ahead and try it on your own and see what you get. Okay? Sorry it was a long video. It's like the last little stuff that needs to get talked about, but it's not the biggest chunk, so just wanted to lump it all together. Alright. Let me know if you have any questions next time we're in class and we can go over them. And other than that, I'll see you then. Alright? Bye!